Solving matrix equations. So we've talked a little bit already about the difference between matrix equations and original equations, or equations involving just algebra and numbers, and that is mainly, the main restriction is that we can't divide when we're dealing with matrix arithmetic. So that's why we've needed the inverse matrix. So we need to first of all recall some properties of matrices. So we know that when we have a matrix and we multiply it by its inverse, that gives us the identity matrix. And when we multiply the inverse by the original matrix, that also gives us the identity matrix. The matrix multiplication here is commutative. We also know when we multiply any matrix by the identity matrix, it just equals itself. Similarly, identity matrix times any matrix equals itself. Again, the multiplication is commutative. We must remember that in general, though, matrix multiplication isn't commutative, so the order that we multiply in is important. AB does not necessarily equal BA, apart from in the two situations above. So we need inverse matrices to solve matrix equations. So when we reach a point where normally we would divide, we need to think, okay, how can I use the inverse matrix in this situation? Alright, so let's just get into some examples so you can see how it works. Okay, so we've got a matrix equation, AX equals B, and we want to solve for X. We're told what A and B are, they're both matrices. So I wouldn't substitute the matrices in first, I would do all the rearranging to make X the subject, and then put in the matrices that I need at the end. So we have AX equals B. I'm just giving myself some space here. So if this was 2x equals 5, we would divide both sides by 2 and be done with it. We can't divide. So rather than dividing, if we instead think about using the inverse. So if I were to multiply the inverse matrix here, that would be helpful because that would become the identity matrix, which is essentially 1. It's the same as in this numerical equation over here, instead thinking about multiplying both sides by 1/2 rather than dividing by 2. It makes this 1, and we've now just got 1x equals something. Okay, so we've multiplied by the inverse matrix on the left-hand side of the equation, so we need to do the same on the right-hand side of the equation. Now what you need to be careful about though is that matrix multiplication is not commutative, so the order that we multiply in is important. So we have to multiply in the same order as we did on the left-hand side. So on the left-hand side of the equation, I put the inverse matrix on the left of the expression. So on the right-hand side of the equation, the inverse matrix also needs to go on the left of the expression. Otherwise, if I put it on the right, I've actually done different things to both sides of the equation because we know that we're going to create a different result depending on the order, the way in which we multiply these two matrices. Okay, so as we've discussed, the inverse times the original, that's just the identity matrix. And we know that the identity matrix times anything is just the anything. And so we've now isolated X on its own. So we need the inverse of A and B in order to find X. So let's work the inverse of A out first. So determinant of A is going to be 1 times 3 minus 2 times 0. So determinant is 3, which means the inverse is 1 over 3. Swap these two numbers around, multiply these two numbers by -1. So there's my inverse. Okay, I don't want to multiply that fraction in because that's going to make the matrix multiplication harder if I've got lots of fractions that I'm dealing with. So we can multiply the number in at any stage in our multiplication. We know that numbers, the order that you multiply in doesn't matter. So we just need to worry about getting the matrix multiplication right. Okay, so we've got inverse of A times B. I'm just going to leave that 1/3 while I do the matrix multiplication and I'll put it in at the end. Okay, so we've got 2 by 2 times 2 by 1, so we're going to get 2 by 1. 3 times 5 plus 0 times 16. 2 times 5 is 10 plus 1 times -16. So 10 plus -16 is -6. Now in this case I am going to multiply the 1/3 in, particularly because both of those numbers will simplify when I divide them by 3. So that is 5 and negative 2. And we've solved the matrix equation. X is a 2 by 1 matrix, 5, negative 2. Okay, another example. So this time we've got the equation XA equals B. Okay, so this time, if I put the inverse over here, like I did in the previous example, I'm not going to be multiplying these two together directly. Remember, the order of the multiplication matters. So inverse of A times X times A must be done in that order, or else you're going to create something different. So it's unhelpful for me to put the inverse here. So I need it to go here, so that it is next to A, so I'll be multiplying them together at some point and they will give the identity matrix. So again, I need to do the same on both sides, and because I put it on the right hand side here, it needs to go on the right hand side over here. So now we've got X times the identity matrix, which is like 1, equals B times the inverse of A. So X equals B times the inverse of A. So now we just need to put our matrices in. So we need the inverse of A. So determinant of A is going to be negative 10 minus 3, so negative 13, which means the inverse of A is negative 1 on 13. Swap these two numbers around, multiply these two numbers by negative 1, and we have our inverse. Okay, so B is negative 1/34. A is negative 1/13. 5, negative 3, negative 1, negative 2. Okay, again, the number can happen at any point in the multiplication, so I'm going to stick that at the front and worry about that at the end. It would be horrible to be doing the matrix multiplication dealing with 13ths, so we won't. Okay, let's do the matrix multiplication. So we've got a 1 by 2 times a 2 by 2, so we're going to get a 1 by 2. We're going to do row times column, so that is negative 5 plus negative 34 is negative 39. Row times right column, positive 3 times negative 68. So 3 minus 68 is negative 65. Now again, I'm definitely going to put my fraction in. Again, be careful, don't use commas in your matrices. It's not an interval, it's not a pair of coordinates, it's a matrix, so no commas. Right, I'm going to multiply this fraction in because both numbers are divisible by 13, and we'll get rid of all those negatives. Negative times negative and negative times negative, so everything will be positive. So 39 divided by 13 is 3, and 65 divided by 13 is 5. So X is the 1 by 2 matrix 3, 5. One more example, a bit more complicated. So this time our equation is AZ plus B equals C. Okay, so it's only division that's restrictive with matrix arithmetic. So otherwise we can do all the same things we would always do. So we want to eliminate B from the left-hand side, so we're going to subtract it. So AZ is equal to C minus B. Now we need to eliminate A from the left-hand side, so we're going to want to multiply it by its inverse. It'll have to go on the left-hand side, so it has to go on the left-hand side over here too. We've got to be careful, we're multiplying the whole, we're doing the same thing to both sides, not just to part of the right-hand side. So we need to multiply the whole right-hand side by the inverse of A in order to have done the same thing. Okay, so we've got the identity matrix times Z is the inverse of A times C minus B. So Z is the inverse of A times C minus B. Okay, again, let's work out our inverse. So determinant is going to be 2 minus 0, so 2. So A is 1 over that determinant. Swap these two numbers around, multiply these two numbers by negative 1. So that's my, inverse of A. And then we also need C minus B. We can do that straight away, but I'll just write it over here. So we're doing the subtraction. you just subtract corresponding elements. So negative 7 minus 2 is negative 9. 3 minus 2 is 1. Okay, so we've got 1/2, 1102 multiplied by negative 9, 1. 1/2. Okay, rows times columns. So we've got a 2 by 2 times a 2 by 1. So it's going to be 2 by 1. 1 times negative 9 plus 1 times 1. So negative 9 plus 1 is negative 8. 0 times negative 9 plus 2 times 1. 0 plus 2 is 2. We're going to multiply in our half. So we get negative 4, 1. So Z is the 2 by 1 matrix, negative 4, 1. So now time to get practicing solving some matrix equations. Good luck!